This is lesson 8.2 on the cosine law, but before we get into that, we want to review what we've done already with regard to sine law. And even before that, we worked with triangles, right angle triangles, where we applied the primary trigonometric ratio, SOHCAHTOA, and the Pythagorean Theorem, a squared plus b squared plus c squared. Then we talked about, well, what if there is no right angle in the triangle, but we have three acute angles? How can we solve these triangles? And one of the answers was sine law. Who can tell us what the sine law is? What is the sine law? What does it mean?
Something that everything
Sine A over sine over A.
One relationship between sides and angles in acute triangles.
Good. So the sine law is one way we relate sides and angles in acute triangles. Cosine law will be the second way that we relate sides and angles in acute triangles. But I'm just going to write down what the sine law is. So if we have the sine of angle A over the side length A, that is equal to the ratio of the sine of angle B and side B, which is also equal to sine of angle C over side C. Now, do we need all three of these parts in order to use sine law? No, we just need two of them. And in fact, we just need opposite information to get one of the ratios, and then any other piece of information will allow us to solve for either numerator or denominator. Okay, so I've drawn three triangles here. You have three triangles on your worksheet. Let's say we have a triangle and we're given this information. We're given angle A, we're given side A, and we're given side B. Can we solve for angle B? If we're given angle A, and we're given side A, and we're given side B, can we solve for angle B using the sine law?
Yes. No.
So if we're given angle A and side A, we can make a completed ratio right here. And if we have side B, then the only piece of information we'd be missing in this equation is the angle B. So if I have this amount of information, yes, I can use sine law to solve that triangle. The key to remember here is having opposite information. Now, let's take a look at another one. Let's say we have angle A, we have angle B, and we have side C. Now, in this situation, can I solve for side A? Take a second to think about this. So if we're given angle A and angle B and side C, can I find the measure of the side length A? And this looks a lot trickier. It looks like I can't because I don't have any opposite information to go off of, but we know that the interior angles of a triangle add to 180. So if I have angle A and I have the measure of angle B, I actually do have the measure of angle C. It's just 180 minus A plus B. Now I have opposite information, angle C and side C, and if I use this part of my sine law and this part of my sine law, I can find the length of side A. Good. A little note here under the sine law. It was noted earlier that we can actually write this two different ways. So we're going to write it the second way as well. This can be written as how we have it. Sine A over A equals sine B over B equals sine C over C. Or we can put the side length on top, which makes it easier to solve for side lengths. So A, the side length A over sine A is equal to the length of B over the sine of angle B is equal to the length of C over the sine of angle C. And then one last note, this is only used in acute triangles. When, or I should say must, have, we're going to go with opposite information. You know what that means by now, right? Opposite information. That means having the measure of an angle and the length of the opposite side.
It's an acute triangle.
So this middle triangle gets a check mark. We can solve that one using sine law. Now, I'm going to give you a third one. Let's say you have side C, you have angle B, and you have side A. And you don't have angle A or angle C, and you don't have side length B. Can you use sine law to solve this? Is there any way that you can get opposite information from this side, and the angle that falls in between them?
Yes.
Pythagorean theorem is a suggestion, but Pythagorean theorem only works in a right angle triangle. So if this were a right angle, we could use C and A to find B. It's not a right angle.
Wait, do you have any other information?
You have C, B, and A.
Oh, yeah, I can see 'cause there's part of it.
The answer to this question is no. You cannot use sine law to solve that triangle. It can't be done. But there is another way. There is the cosine law, which we're going to learn about today. Okay, through the investigation, we tried our best to grab the formula for the cosine law. It looks like this. And question 7 asks you, what happens if we find if angle C is 90 degrees? So if we subbed in 90 there for cosine C, what actually happens if you type it in your calculator, the cosine of 90 is 0. So this whole part gets multiplied by 0. It doesn't matter what A and B are. This whole section is going to be 0, which just leaves you with this. What does that look like? Pythagorean theorem, which works in a 90-degree angle. Okay? So this formula is very closely related to Pythagorean theorem, but it works in all acute triangles. It also works in a right angle triangle, because in a right angle triangle, this whole side just becomes 0, and you're left with Pythagorean theorem. Okay? So that's how they're related. We're going to take a few notes on the top of the next page. The first note is on just the cosine law. What is it? And it's very similar to the definition of the sine law. It is the relationship between the cosine of an angle and the lengths of the three sides in any acute triangle ABC. So the relationship between the cosine of an angle and the lengths of the three sides in any acute triangle, just the symbol for triangle. You don't have to write the word triangle. A, B, C. The relationship between the cosine of an angle and the lengths of the three sides in an acute triangle ABC. So that's basically just telling you what's involved in the formula. The cosine of an angle is involved in the formula, and the three sides are involved in the formula. So A, B, C side lengths, as well as one of the angles. It doesn't matter which one. In fact, we can use cosine for any of the three angles. We just need to write it in a different way. So for instance, if we want to find the length of A, we use it in this form. We use A squared is going to be equal to the other two sides squared minus 2 times the other two sides multiplied together. So the product of the other two sides times 2 times the cosine of A. So the things to remember here.
Is there a song for
There probably is a song for this, but I don't know it. So if you're looking for side A, then you have to remember that the angle A is on the far other side, and the two other side lengths are right here and right here. Does that make sense? So that's how you remember this formula. If you're looking for a side, then the opposite angle is at the end, and the two other sides are involved here. And it really doesn't matter which way you write this, because b squared plus c squared is the same as c squared plus b squared, and b times c is the same as c times b. So if you mix up the order, it's not a big deal. If we were finding side length b, we would write it this way. The other two sides would be over here, a squared plus c squared. We'd go minus those other two sides because we know those lengths, and times the cosine of the opposite angle, which in this case is now b. There's a third form to this equation to help us find the length of side C. I'm going to let you do that one on your own. You can check my board afterwards to see if you got yours correct. Okay, you can check the board to see if you got the right answer. Again, it's just if you are looking for side C, then you know sides A and B, and you know sides A and B, and you know angle C. So all the information, it looks like a long formula, but all the information on this side is known, and you just plug it in and go for it. And then at the end you have to remember to square root it, which is what we'll go through in some of our examples. Okay? We're going to derive the formula. It's a few steps. Hopefully you have some space left over on your page there. And we're going to be using the diagram that's given for you in the top right of your page. Can everyone please identify triangle ABC? Have you found triangle ABC? Good. The altitude, which has a length of h, is the line segment CD. Now the altitude splits this triangle into two different triangles. Can you identify the two different triangles? ACD and BCD, and it's been noted that they are special triangles. They are both right triangles. Okay? Now, we can let the length AD be x. So, what we're gonna just take a step of notes here. Okay? So, the altitude, comma h, splits triangle ABC into two right triangles. We'll call them ADC and triangle BDC. Now, why might we want to split this into two right triangles? We have lots of tools that we know how to use in right angle triangles. So now we can use them. In your diagram, the line segment AD is labeled X. So we're going to let AD be X. Then, if AD is X, then BD equals C minus X. Can you see that in your diagram? You have the length of C. So C minus X is DB. And that is already labeled for you. Okay, let's look at triangle ADC. So focus on triangle ADC. If we use the Pythagorean Theorem and we used our side lengths in triangle ADC, what would the Pythagorean Theorem look like? What would the Pythagorean Theorem look like? In triangle ADC. Let's go, people.
A squared plus C.
Yeah, we don't have an A in that triangle anymore. The side lengths are already labeled for you, so use the labels that are there.
H squared plus x squared equals b squared.
Very good. So b squared equals h squared plus x squared. Well, what else can we say if we're doing the cosine law? So let's use the cosine ratio. What is the cosine ratio? Cos of an angle equals toa. So adjacent over hypotenuse, right? So let's look at the cosine of angle A. What are the side length labels? What are the labels that would be adjacent and hypotenuse? If we're looking at cosine of angle A. Well, adjacent is x and hypotenuse is b. So this is cosine of A equals x over b. Okay, we're just gathering some information that we already know using this right angle triangle. So now we have b squared equals h squared plus x squared, and we have the cosine A equals x over b. Okay, we can rewrite this in terms of x. How do I get just x on this side? Well, if x divided by b equals the cosine of A, then x must be the product of b and the cosine of A. Right? If we had a division triangle, remember your division triangles from science? So we've got x at the top and both of these guys in the bottom. So the product of A, the cosine of A and b is x. So x equals b times the cosine of A. Okay, we're just manipulating what we already have, what we already know. Okay, store that information on your page. We're going to come back to it in a second. And now we're going to focus on triangle BDC. So I'm going to erase what I have. And we're going to focus on triangle BDC. So let's use the Pythagorean Theorem in triangle BDC. How would we write that? How would we write that in triangle BDC, the Pythagorean Theorem?
C minus x squared plus h squared equals a squared.
Good. So you've identified the hypotenuse as a. So we have a squared is equal to the sum of the squares of the two other sides. So it's h squared plus, and then here our last side, db, is c minus x squared. Can you all see that makes sense in your triangle? Make sure you keep double checking your triangle at the top to make sure you understand what's happening here. So all we're doing is using Pythagorean Theorem, but one of our lengths is c minus x. Okay? And we've already written what x is equal to in the other formula. So these two are going to come together. So now all we're going to do is expand this binomial. This is a binomial, and we know how to expand it. We're going to FOIL this. So we're going to have a squared equals h squared. And if we FOIL this, we've had first times first, last times last, outside times outside, inside times inside. But we also know that we have a difference here. But here we go. So we've got c squared minus 2cx plus x squared. Okay, this is from a couple units ago. And we're going to rearrange that so that you can see exactly what's happening here. Okay, so we're going to rearrange this. We have x squared plus h squared plus c squared minus 2cx. We haven't changed anything, so up here if you're making notes on the side you can say expand, and then to get to the next stage we rearranged. So this is the mathy part. And now we're going to substitute what we know from b squared for x squared plus h squared. Okay, so in the beginning, in the last triangle, we already learnt what that b squared was x squared plus h squared. Good. And we already learnt that x over here was b times the cosine of a. Does that make sense? So we're just substituting. Substitute. Just showing you how this is derived. So in the last time, we found out that x squared plus h squared is actually equal to b squared. We have still plus c squared. And we still have 2c. But we found out from the last triangle, from triangle ACD, that x is equal to b times the cosine of a. And we write it in those brackets. We'll erase the brackets in a second because we don't actually need them because it's all multiplication. But all we did is substitute what we know from triangle ADC into what we know from triangle BDC. And can you see the cosine law coming through here? So because this is all multiplication, 2 times c times b times the cosine of a, we can rearrange that however we want to. And we end up with a squared is equal to b squared plus c squared, the two other side lengths in the triangle, minus 2 times b times c times the cosine of a. This equation allows us to find the side length a if we already know the side lengths b and c, and we know the angle a. Okay? So this is how you would derive it. You can derive the other two forms of the cosine law in the exact same way, but you already wrote them down, and it works the same way, so we're not going to do that. Example 1, here we go. Find a side length using the cosine law. Okay, you have a nice little picture there. Please look at it and read along with me and identify the important information. A boat is sailing north. So you've got the boat there at the bottom of the diagram. It's sailing north through a narrow strait. Through one particularly narrow section, a lighthouse marks the western shoreline, while a buoy indicates a rock hazard directly east of the lighthouse as shown. What is the width of this section of the strait to the nearest tenth of a kilometer? So what are we trying to find here? Somebody tell me what we're trying to find here. Well, nothing is labeled yet. The width of the strait.
The width
which is
this section of the strait.
In between the lighthouse and the rock, right? On your picture. Okay, so we're trying to find the side length that is opposite the angle that's given. And look at the information that we're given on the diagram. We're given a side length, and the contained angle. So that 26 degrees where the sailboat is, that's called the contained angle. Because it's in between, it's contained by the two side lengths that were given. Okay, so to solve this, first step we're going to do is we are going to simplify this diagram. So we're going to draw a simplified diagram and we're going to label it. Okay? So we have a simplified diagram. Remember, it's not a right angle triangle, although it looks pretty close to it. Your diagram should look something like that. We've got the rock over here, that's R. We have the boat down here, that's B. And we have the lighthouse over here, that's going to be H for house. Which means that the side lengths are called B, R, and H. Alright, now let's fill in the information that we know. Angle B is 26 degrees. The side length R is 4.2 kilometers, and the side length h is 4.5 kilometers. So in this situation, we are looking for the length of side B. We have the two other sides and the opposite angle. We have angle B. So let's write the cosine law, because that's what we're going to be using, in a format that uses the variables that we have here. So if we're finding B, then we have B squared is equal to the sum of the squares of the other sides, so that's r squared plus h squared, minus the product of 2 times the two other sides, that's 2 times r times h, times the cosine of the contained angle, that's angle B. So there's our cosine law, exactly how we wrote it before, but we've changed the names of the variables to match our diagram. Instead of using ABC, we use BRH. So let's go.
I'm confused. If we wrote it all here, why did we have to do this right here?
Okay, so let's fill in the information that we know. We're finding B squared. At the end, we're going to square it to find the length of B, but we can fill in what we know. So B squared is equal to R squared. Well, R is 4.2, and we're going to square that. H is 4.5. We need to square that. And then minus 2 times R, which is 4.2, times H, which is 4.5, times the cosine of B. B is 26, so we're looking at the cosine of 26 degrees. Please get that down. Now, if you have a really nice graphing calculator, you can do all this in one step. If you don't, you're probably going to do it in 2 steps. But most of your calculators are smart enough to do it just kind of the first part and then the second part. So we can break this down step by step. Let's do 4.2 squared plus 4.5 squared first, and then we'll see where we're at.
4.2 squared is 17.64.
Cool. 17.64 plus, what's 4.5 squared? 20.25, and minus this whole thing. Let's do that all in one step. So I would start with, especially if you have an old calculator, do cos of 26 first. So I actually have to hit 26 cos, and then you can go times 2 times 4.2 times 4.5. Did everyone get 33.97? Perfect. That's wonderful. Okay, and we can add those guys up. 17.64 plus 20.25 minus 33.97. Should get 3.92. Yeah, doing it all in one step is going to be better because your calculator doesn't round the answer. Okay, so we rounded this answer, so our answer already is not perfect. It's approximate. Okay, if you can chuck it all in one go, do that. If not, you can break it down into its parts and do it step by step. But that's only B squared. So B squared is 3.92. How do I find B?
Unsquare.
To unsquare means a square root. Take the square root of both sides, and we get that the length of side B is approximately 2 to the nearest tenth, 2.0. So double check your question. It says to the nearest tenth of a kilometer.
1 point.
So we solved for side length B, which was the goal of this example. So the width of the width of this section of the straight, STRAIT, is approximately 2 kilometers. And again, all we did was we took our cosine law, we substituted in the variables that were in our diagram, and then we plugged in all the values. And look, we have no unknowns on this side. We knew every single value. Just had to put them in our calculator, get b squared, square root it to get your approximate final answer. And that one is done using the cosine law in an acute triangle when we have 2 side lengths and the contained angle. Okay, in example 2, if you read that on your own, try and figure out what it means. And the best way to think about drawing a diagram is to remember that you have 2 side lengths and the contained angle. So what you want to do is you want to start with that angle. So you think, what is 64 degrees look like? Well, 64 degrees looks about like that. Okay, so start with your angle of 64 degrees. It's angle E. And then you have the 2 other sides. Well, it doesn't really matter which side you use to be D and which side you use to be F. It just matters that one is longer than the other. I already have one side that's drawn a little bit longer than the other. So I'm going to use this as F equals 6.2 centimeters. If you wanted to use your ruler, you could actually draw out 6.2 centimeters, though you don't have to. And I'm going to finish off by coming down here. It almost looks like an equilateral triangle or an isosceles triangle, but it's not. And my other arm here, which is D, is 4.9 centimeters. Alright, so I have the information that I know. It's not a right angle triangle, it is an acute triangle. And I know my other labels as well. If this is side length D, then this must be angle D, capital D. If this is side length lowercase f, then this must be angle, capital F. And this missing side length must be side length E. So in acute triangle DEF, D measures 4.9 centimeters, F measures 6.2 centimeters, and angle E measures 64 degrees, and we need to solve triangle DEF. What does it mean to solve a triangle? Find all the missing side lengths and angles. Okay? We're going to round our measurements to the nearest degree or the 1/10 of a centimeter if necessary. So we've already drawn our diagram. Why don't we attack side length C, side length E first? Okay? So step 1, we're going to find side length E. How are we going to do that? We have the 2 other sides and the contained angle. This is cosine law.
Can't you just do cosine of that 6.2 over 4.9? And that's it?
If you had another angle, you could use the sine law.
Well, you can't use the side lengths?
We don't have any other way to find E except using the cosine law. Yeah, it's not a right triangle.
Right.
Yeah. So that's a tough part to remember. So we're going to find side length E, but once we have side length E, we'll have opposite information. We can use sine law after that. Okay? So let's go ahead and find sine length E. We're looking for side length E using the cosine law, which says E squared is equal to the sum of the squares of the other sides. That's F squared plus D squared, minus the product of 2 times the length of the other sides, times the cos of the contained angle. So that's 2 times F times D times the cosine of E. And again, all you have to remember when you're using this is that if you're looking for side length E, then the angle E is way on the other side. It's part of the information that you know. If you don't know one set of opposite information, or if the formula doesn't contain opposite information, then you can't use it. Okay? Fill in what we know. E squared is going to equal f squared, which is 6.2 squared, plus d squared, which is 4.9 squared, minus 2 times f, which is 6.2, times d, which is 4.9, times the cosine of angle E, which is 64 degrees. Everything there is plugged in. All you should have to do is put the whole sentence in your calculator. I'm going to see if my little calculator can handle this.
Mine did.
Mine won't be able to, but I can do big chunks of it. So I can do 6.2 squared plus 4.9 squared. Should be 62.45. That was both of these parts. And then we just have minus. Now I have to do 64 cos. Times 2 times 6.2 times 4.9 equals 5.47876. I don't want to round too early. And I'm going to do the last step, which is just 62.45 minus this whole hubaloo, 5.47876. And we should get that E squared is approximately something went wrong with
I
mine.
got the 35 one.
Yep.
I just wrote mine all in and I got
E squared should equal 35.814, etc. Which means E equals the square root
That was not triangle.
of that. So E equals approximately 6 centimeters. E equals approximately 6 centimeters. Okay, let's add that 6 centimeters to our diagram. And what should we solve for now? Okay, we're going to solve for angle F. Now that we have angle E and side E, what can we use to solve for angle F?
Sine Law.
Yeah, we don't need to use cosine law this time. We can use sine law. So, find the measure of angle F using sine law. What opposite information do we have that's going to give us our ratio?
Sine 64 degrees over 6. And then sine f over 6.
So I'm going to use our variables each time. So we have E and E. So we've got sine E over length E. And then because we're solving for F, we're going to use sine F over length F. That's sine law. Sub in what we know.
Would we be able to use the other way on this one or no?
You could, but because you're solving for angles, it's easier to put the angles on the top. If you put the angles,
like that
cosine law,
like thing in there.
you can, but it involves rearranging cosine law. So it involves knowing what's on this side already and not knowing one of the pieces over here. So it's not as easy, but it's you will learn it at some point in your life. Okay. So we've got sine of E, which is sine of 64, over the length of E, which is 6, is equal to the sine of F, which we don't know, over the length of F, which is 6.2. And now all we need to do to get sine of F by itself is multiply both sides by 6.2. So we've got the sine of F is equal to 6.2 times sine of 64 over 6, and that's just from last lesson on sine law and rearranging equations, which means now all we need to do is take the inverse sine of both sides. So the measure of angle F is equal to the inverse sine of 6.2 times sine of 64 over 6. That looks like a big mess, but your calculators should be able to handle it. If not, then you can calculate this part before taking the inverse sine of it, or you can just write it like this and then do what's in the bracket before taking the inverse sine of it. So you'd have sine of 64 divided by 6 times 6.2.
What did you do?
Can't you just...
Should get in the bracket 0.9287 and then we take the inverse sine of that.
So when you take it, you go.
I got 68.2. Yeah, but I just set the entire thing on the calculator. So we can do...
And we're rounding to the nearest degree, so we can just go approximately 68 degrees. Do you guys have questions on that one?
You did it really weird.
Okay, now that we have the measure of angle F, which is
We used to 180.
68 degrees, how are we going to find angle D?
Add, subtract, and then...
Yeah, the measure of angle D is simply 180 minus 68 plus 64, which in your calculator equals 48 degrees. And this triangle is solved. We have found all the side lengths and all the angle measures. Quickly looking down at the bottom at your key concepts. Your key concepts. I'm erasing this. Hopefully you kept up.
Can you move
48 degrees. Your key concepts. In an acute triangle ABC, the cosine law states that a squared equals b squared plus c squared minus 2bc cos a. You already wrote those in your notes, so we're going to go down to the next one. So in that section, you're going to write all three forms of the equation again, and you need to memorize it. Okay?
Wait, oh.
The last bullet says, the cosine law, which you should know, the cosine law can be used to find a missing
Sideline.
side
Side.
if the other two
Angles. Sides.
sides, the other, there's a keyword, other two sides, and their contained angle are known. Call it the contained angle. So if you have two side lengths, side length A and side length B, then angle C is their contained angle. Does that make sense? Okay, so this is our contained angle. Your homework is at the bottom of your sheet. Please do it. Please keep up. I will also be running exam prep every Tuesday at lunch just for like the first 20 minutes. There'll be like a mini lesson of Unit 1. We'll just quickly review what the concepts were in Unit 1.
today?
Every Tuesday. Yep, just 20 minutes. So that's less than half of your lunchtime. If you just stay here right after prayer, we whip through it. If somebody's here, we'll do it. If nobody's here, we won't do it. Yeah?